Hi everyone, let's look at more substitutions. So these examples are going to continue the substitution steps, but look at more involved examples. So let's start with this one. You've got this first line, 2x plus y equals 1, and a second line, x plus 3y equals minus 2. Remember, if you graph these, they are lines, okay, and they will intersect. At least there's a chance they intersect, and we call the intersection point a POI. All right, when we do substitution, the first thing we need to consider are any of the equations presented so that a y or an x is all alone, all by itself on one side. So in this one, we see that it's 2x plus y equals 1. No y is embedded with 2x here being added to it. And in this one, well, there's a x plus 3y. So we don't have any spots where x equals something or y equals something. All right, so when you see that, you have to be able to see that, and then you make this change. You do what's called rearranging, okay? So it's called to rearrange, all right? So if this is equation 1, and this is equation 2, what we see in equation 1 is y, and he is by himself, kinda. There's 2x added to it. Well, what if we make this change? Remember we said we can send over this term to the other side of the equation, and when a positive 2x jumps sides and moves to the right side of that equal sign, it just becomes subtract 2x. So you can actually rearrange equation 1 such that it now looks like this. So remember, 2x is jumped over. It says plus y, which I know to just be y. Carry my equal sign down. I still have the 1 there. And then that 2x came over and became minus 2x. So now I've got like a new equation 1, or more like a rearranged one. And then we go back to our steps for substitution, where now that y is by itself and it equals something, okay, we can substitute all of this into the other equation where we see a y. And this is what we write. We write sub. You have to write this out. You need to write sub the parts of equation 1. So that means equation 1, sub the parts of equation 1 into equation 2. And here's the actual step, okay? So I'm going to write out equation 2, but instead of writing y, I have to write all of this, 1 minus 2x, because that is equivalent to y. Here we go. I'm writing equation 2, x plus 3 times y, and I see it's time to substitute. So I put insertion brackets, and I don't write y, okay? I write his equivalence, 1 minus 2x. It goes in the brackets, okay? So I've written x plus 3 times what y has been substituted for, and now I have to write the equal minus 2. And take a look what you have. You essentially have equation 2, but instead of the y, you've got that substitution, okay? It happened right here. Then you need to go back to some skills you learned in grade 7, 8, 9, pending, and we have to start solving this, but first you have to do the distributive property. The distributive property works like this. Here's where we need it. So it says x plus 3 times everything in the brackets. Here's where you use distributive property. 3 has to multiply, you show with arrows, everybody in the brackets. Everybody in the brackets is tripled. So let's update. X stays there. 3 times 1, a positive 3 times 1 is plus 3. 3 times 2x, and it's negative 2. Well, the positive 3 with the negative 2 is going to make this result negative. 3 times 2 is 6, and we leave the x beside it. Okay, and we're done. We've gotten rid of the brackets, and then there's a minus 2 here. Okay, so we're going to continue with our solving skills. On the left side of the equation, I see that x can be worked with this x. So you have 1x here. Okay, remember, even though we don't show the 1, you have to remember there's a 1 there. 1x, take away 6x. It's like having $1, take away $6. You would be down $5 or negative 5x. Okay? Now, what about this positive 3? He actually belongs on the other side with the number because they're like terms. So I'm going to do this. I'm going to send this 3 over. All right, and I know I'm doing that so the numbers are collected together on the right side over here. So let's take stock. I have the subtract 2, the minus 2, and then I sent over the 3. It becomes subtract 3. Now all I'm left with is minus 5x equals, well, if I'm down $2 and down another $3, I'm down $5. So to finish solving, we have minus 5 times x equals minus 5. We have to undo the multiplication of minus 5 times x by dividing. It's minus 5 times x. You divide by minus 5. It will undo that. And you have to be fair and do it on the other side as well with everything, including the sign. So you divide by 5 with a negative. Okay, so let's update. Minus 5 divided by minus 5. You would just be left with x. Cancel those out. Carry your equal sign down. Minus 5 divided by minus 5 is 1. Okay. So we've realized x is 1. When you do substitution, the goal is to find the x value and the y value. All right. So you need a second substitution. You're going to sub x equals 1, which was one answer, and you'll put it into the equation that has the y by itself. And that makes your life easier, which happens to be this one here. Y equals 1 minus 2x was our first equation. So you'll sub it in number 1. Okay, so here we go. I'm going to rewrite equation 1 here. Y equals 1 minus 2x. And anywhere I see an x, now I'm going to substitute a 1 in. So 1 minus 2 times, put your insertion brackets, and now it's time to substitute right here. Put the 1 in. Now you have to do the math. So let's do the math. 1 take away 2 times 1. We have to do 2 times 1 first. So it would be like 1 take away 2. And we know if we have one thing and we lose 2, we would be down 1, or we would have negative 1. Okay? Now you have 2 values, x equals 1 and y equals minus 1, which we can conclude are POI, which we write as a point. X goes first, then y. Okay, so here we go. Our POI, our x value was 1, and our y value was minus 1. So that's where these two lines, if graphed, would intersect, the POI. Okay, example 2. We've got 2 new line equations, and let's label them. Number 1, number 2. Always add those labels, okay? And go in order, 1 and 2. Let's take a look at, well, number 1 here. Number 1's got 3x, subtract y equals minus 4. None of the x's or the y's are by themselves. Well, we can rearrange. So again, we're going to rearrange. Okay? And there's a couple things that have to happen to rearrange. We're going to want y by itself, and that means it can't be negative. So if it says minus y, the only way to get him by itself is if he changes sides and comes over here. When you bring that minus y over to the right side of this equal sign, it will become a positive y. All right, the only other thing that has to happen now is this minus 4, he needs to change sides. So the y ends up being alone. Okay, so let's update number 1 down here. 3x hasn't moved. Okay, we'll keep the equal sign. Now remember, we sent minus y over, so this bit here, and that means on this side it's just y now. And then we sent negative 4 over to this side. Okay, so it's 3x, negative 4 becomes a positive 4. All right, so we've got a new number 1. We'll go to our step of subbing. 1 in 2. All right, so we're going to substitute our new number 1. Anywhere we see a y, we write 3x plus 4 in number 2. So here's number 2. 2x subtract 2. 2x subtract 2. it multiplies a y. So now I open up my substitution bracket and I do my sub. Y is 3x plus 4. 3x plus 4. Great. And now I close this. Okay, so it's 2x minus 2, substituted y equals 8. Okay, now we have to solve. First thing I notice is a bracket with a 2 in front. You need the distributive, so I'll just write dist PR, the distributive property. That negative 2 multiplies everybody in the brackets. So let's update. 2x minus 2 times 3 minus 6, keep the x. Minus 2 times 4. Well, 2 times 4 is 8. And I know he stays negative because a negative with this positive leads to a negative. Okay? Equals 8. Now let's look on the left side for some like terms. Okay? The x's can work together. If I have 2 of something and I take away 6, 2x take away 6x, I would be down 4x. Grab your calculator if you have to. 2 minus 6, you'll find it's minus 4. Okay, so that took care of these two. Minus 8, there's nothing on the left side he can work with, but if you send him over to the right side, remember we said you can do that. You send this term over to the right side, he'll change signs, okay? It'll end up being this 8 stays there, the minus 8 comes over and you have to add it, plus 8, okay? Let's update. So minus 4x, there's nothing happening to it. Keep my equal signs. 8 plus 8, 16. Okay. Minus 4 times x, I want to undo that multiplication by dividing. And I have to do it to both sides with the sign. Don't forget the sign. It changes everything, okay? Minus 4 divided by minus 4, I'm left with x. 16 divided by 4 is 4, but a positive number divided by a negative number makes for a negative answer here. And there's the first part of your POI, the x value. All right, anytime we do substitution, we need to find the unknown x value and the unknown y value. Now that we know x is equal to minus 4, we do the following. You always substitute your first answer. So our first answer we found here is x equals minus 4 into, typically it's that very first equation, okay? But the rearranged version, okay? Because remember at the start, the very start, we had this number 1, and then we did our rearrange, and we end up with this second number 1, like an updated number 1. It's much easier to find y in this one, because y equals everything on this side. It's nice and clean. So I'm going to sub x equals minus 4 into the rearranged number 1. Okay, so here we go. I'm going to rearrange number 1. It says, now I know it says 3x plus 4 equals y, but I would rather, think left to right and write it this way. Y equals 3x plus 4, and now it's time to substitute. Okay. 3 times minus 4 plus 4, that's minus 12, plus 4. If you were down $12 and you add 4, you're now only down $8. And there you go, there's your y value. You've got your x known, you've got your y known. You can conclude that the point of intersection, okay, we list the x first, then we list the y. So x was minus 4 and y is minus 8.